We left you with a real cliffhanger there. Sorry about that. Got cut off finishing this one. So we divided just 7/12 to find the decimal portion of this number. I know that 8 is my whole number, so that goes in the ones place before my decimal point. And now dividing 7/12, I find that that equals 0.583 repeating. So if this is the size of my plane, 8.583 repeating, I know that that is less than 8 7/10, so this plane will fit through this space. So let's go ahead and move on to your second vocab term for today. So this is the other graphic organizer that you have is for terminating decimal. So we are going to look at terminating decimal. You can write this in the middle, and the definition is that a terminating decimal has a decimal expansion that ends in zeros. So let's take 3/4 as an example. So you could put this in your example section. Remembering again that a fraction represents division. This means 3 divided by 4, which we can represent in long division in this format. And as I divide this out, you'll notice that I get down to a remainder of 0. And when I get to this point in long division, I know that I have reached the end. So truly, this trail of zeros would go on and on and on forever. However, it's a lot simpler to drop the zeros and just call this decimal 75 hundredths. So that's what we'll do. So that's what a terminating decimal is it's one that ends in zeros. So there's no repeating term at the end, no repeating place at the end. It simply ends in zeros, although we typically don't write those. So let's look at a few common fractions and their decimal expansions. A lot of the common fractions that you know would be examples of terminating decimals. So you could put these on your list as examples. 1/2, 1/4, 1/5, 1/10. Hopefully those are all decimal expansions that you have memorized. If not, you may want to start committing those to memory. If you're looking for non-examples of terminating decimals, you could list some of these common fractions and their decimal expansions for which we see the fraction bar. Oops, and we missed one more example. 1/8 would also be an example of a terminating decimal because it ends. So remember, terminating means end. So let's look at some more examples. Take a second to pause the video and look through these and see if you can determine the best spot for each of these decimals, and then unpause when you're ready to check. All right, so as we check out these decimals and fractions, the ones that terminate, over here on the left, we can see for all of the decimal versions that they have neither the ... nor the repeating bar. So these have a clear end. They terminate. 1/8 we would have to actually divide out on our calculator or using long division to find that it does terminate. 1/8 decimal expansion is 0.125 and it ends there. So that would be a terminating decimal. However, some non-examples would be 0.84 ... because that indicates that this decimal goes on forever without ending. 1.72 has the repeating bar in it, so if it's repeating, it is certainly not terminating, as those are opposites. And I know that 1/6 and 1/3 both have decimal expansions with a repeating digit, so these would be non-examples of terminating decimals. So your turn. Let's take a second and label which of these are terminating. Number 1 is fairly obvious, no ... no repeating bar, so that has a clear end. Decimal number 2 as well has a clear end. Decimal 3 is clearly not a terminating decimal because it has the dot, 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 but don't be tricked on number 4. Number 4 is not a repeating decimal, even though it only has 3's and 0's. It has 3 followed by 2 zeros, and then a 3 followed by 3 zeros, and then a 3, but there's no dot, 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 and even within these digits, there's no repeating pattern. So don't let that fool you. Let's think about 407 real fast. 407, is that a terminating decimal? And explain your answer. So as you think about the number 407, if I wanted to expand it as a decimal, this would have a series of zeros following the decimal point. But I typically don't write those because it's a little bit redundant. We understand 407 to have the same value as 407.0000. So this would be an excellent example of a terminating decimal because it ends in zeros, so it has a clear end to its non-zero digits. Let's try a practical application here. So a recipe for a 6-foot sub calls for 3 7/8 pounds of sliced deli meats. You want to get the exact amount from the deli counter. What decimal number should the digital scale show? So again, with a mixed number like 3 7/8, 3 indicates the number of wholes. 7/8 represents our fractional piece, or the part of another whole. So the 3 is going to be in the ones place before my decimal point. And to find the decimal expansion for 7/8, I will do 7 divided by 8. So to work this by hand, I can go ahead and add some zeros. And now I am looking at how many times 8 will go into 70. So I know that 8 times 8 is 64. And that's a difference of 6, so I'll bring down my 0. And now I know that 8 will go into 60 7 times. 8 times 7 is 56. That's a difference of 4, so I'll bring down my 0. And 8 will go into 40 5 times. 8 times 5 is 40. When I subtract, I get 0. So because I have subtracted down to 0, I know that my long division is complete. So in this case, I am looking for 3.875 pounds of sliced deli meat. And finally, to wrap up all of our decimal fun today, let's talk about why this decimal is not a terminating decimal. So take a second to study it. And we discussed at the beginning with our definition that a terminating decimal ends in 0. So what is different in this case? And let's bring your answers to class tomorrow to discuss. Go ahead and log into Digits if you care to tonight to check out this 3.1, 3.2 homework. You will, however, have class time tomorrow to work through this as well. So I will be available to help you and answer any questions you have. But let's bring some topic of conversation for this question tomorrow. We'll see you later. Bye-bye, everybody.